Okay, so here we're going to look at a couple of problems. So, number 5, it says walk 80 meters at 75 degrees north of west, then you turn and walk 120 meters 60 degrees north of east. What is the angle of your resultant? Okay, so let's do this. So this is number 5 here. So first thing you need to do is draw an origin. So if we're right here, then we can go first 80 meters, 75 degrees north of west. So this is north, west, south, and east. So north of west. So this is the west line here. And so we're going to go this way at 75 degrees. So then it looks something like that. So we got 80 meters. 80. Okay, so we got that. Now, then it says you're here and you turn, and you walk 120 degrees, or 120 meters at 60 degrees north of east. So this thing is right here right now. And so north of east would be this way. That should be longer, I guess. It's 120. This is 60 degrees, 120. And it says, okay, find the angle of your resultant. So the resultant is going to be from where we started here all the way up to there. That's our resultant. So the angle of the resultant is actually this angle right here. So the easiest way to do this is to take each vector and break it into its parts. So you can do this first vector here. This will give us a west side and a north side. And then this one will give us a east side and again north side. And the plan is to put the west and the east together to give us a small, probably eastward vector here. And then we'll do north plus a second north to give us a very tall north vector this way. So, to do this, we're going to use sine and cosine. So, to find the x part of the 80, I'll just call it vector 1. Remember, that's going to be your displacement times cosine theta. So let me write this up here. So we've got let's say the adjacent side is cosine of your angle times your hypotenuse. And I don't like the way that's written. So let's say hypotenuse times cosine theta. And we also know for the other one, we're going to use opposite is h sine theta. So, to find the x component of this guy right here, we're going to do 80 times the cosine of 75. And we'll get a number. So about 20.7. And then we can find the y component of the first vector. So this again would be 80 sine of 75. And so I get 77.21. Now, this one is going to be going north, so if we call north positive, and this should be positive. This is going west, and usually we call east positive, so I'm going to put a negative on this, which means it's going back this way. So then I can find the x component and y component of our second vector here. So we'll just do 120 times cosine of 60, and 120 times the sine of 60. So x2 y2, we can find that. So x2 is going to be 120 cosine 60. So that's 60 meters. And this is east, so we'll say positive. And then we're going to do 120 times the sine of 60, which gives us 103.9 meters. And again, north, so that's positive. So now I'm going to add x1 plus x2 to get my x. And I'll add y1 plus y2 to get my y. So x1 is negative 20.7 and x2 is 60. So those are obviously going to subtract. 39.3, and since it's positive, that will be in the east direction, so that's this part right here, 39.3. And then I'll do 77.21 plus meters plus 103.9 meters. This one plus this one. 181.2 essentially meters. And that's this side, 181.2 meters. Okay, so it's asking us to find the angle of our resultant, which is right here. So always to find angles, we use tangent inverse of opposite over adjacent. So in this case, opposite, you'll see that, I don't think. Make this bigger. So opposite over adjacent. So opposite would be the 181.2, and the adjacent would be 39.3. Tangent inverse of 1.2 by 39.3. And we get an angle of about 77.8 degrees. And that would be north of your east line here, because this is east, right? So north of our east line. Alright, let's look at the next one here. So, got that one. Oh, looks good. What's the next missed one on this one? Here we go. A climber throws a rope downward with a velocity of 6.7 to another climber, 12.7 meters directly below. What's the magnitude of the rope's velocity when it reaches the lower climber? So if we set this up, we can say our origin is up here when he drops the rope. And if we say down is negative, so we've got to be careful. So he throws the rope down to his partner down here. Okay. So we have some things. We have a velocity. In this case, it's initial vertical velocity. He's throwing it down. So if I say down is negative, then it's negative 6.7 meters per second. Then he throws it to a climber down there. So we could say that he's initially at 0 and he throws it down. So that would be negative 12.7 meters. Okay, what's the magnitude of the rope's velocity when it reaches the lower climber? So we're looking for our final velocity. So in order to do this, we know these things. We also know our acceleration of gravity. In the y direction, we could say that's negative 10 because it's downwards, meters per second squared. So we know all of this and we don't have time, so that's going to be our third kinematic equation. So Vy squared is V naught y squared plus 2ay y minus y naught. And we're going to solve for the velocity when we reach the lower climber. So we're going to solve for this. So Vy squared equals negative 6.7 squared plus 2 times negative 10 times negative 12.7 minus 0. So Vy squared equals 6.7 negative 6.7 squared. It's going to become positive after you square it. 44.89 plus 2 times 10 times 12.7. Again, that'll be positive. Is 254. Technically, we also need to distribute this to the 0, but it's obviously going to be 0. So now we just add those two numbers together. So Vy squared equals 298.89 and then we'll square root both sides to get Vy. And remember, this could be plus or minus, so we'll have to select one. And taking the square root, we get 17.3 meters per second. And since we threw it down, we know that we're going to use the negative root there. And that's our answer. We'll go ahead and stop right now.